The next book is a book on mathematical statistics with resampling and R, von Chihara and Hesterberg. And I initially bought this because it was a mathematical statistics book, meaning they would do things rigorously, but they didn't really. So I think the book was not really a good buy for me. It does do a lot of advanced statistics, like here we see the bootstrap, which is not something you would cover in initial courses. It does inference, confidence intervals, it does hypothesis testing, so it does all the themes and topics of statistics and of initial statistics, Bayesian methods even. And it gives the course in R, meaning how to actually do it. So yeah, if you are looking for a book which does statistics with R and which basically shows you how to do things in R, then this is a good book. But I think the title, Mathematical Statistics, is quite a misnomer. I don't think it is actually mathematical statistics at all. So yeah. It's not a bad book for what it is, just, I guess, mistitled. Good luck finding the next book, Abdul. It is the book Expectiles and Their Application in Economics and Statistics by me. It is my master's thesis in statistics. And yeah, I'm not sure if I should have presented it, but it's what it is. So yeah, it deals with expectiles, of course, and how it applies in different situations. So we have expectiles and applications, then we have generalizing expectiles to M-quantiles, then we have expectile regression. In this book, I managed to prove anew some things that I think were kind of new. But yeah, we never really published it or bothered to publish it. And I don't even think it was really new to begin with. But this is a work I'm really happy with. Next, we have Multivariate Statistical Inference and Applications by Rencher, which is basically my favorite multivariate book on multivariate statistics. So it deals with usual multivariate topics, starting from the random vectors and matrices, the multivariate normal, then we have the Hotelling t-square tests, we have multivariate analysis of variance, we have discriminant analysis, classification of observation into groups, we have multivariate regression, canonical correlation, we have principal component analysis, we have vector analysis, and that's basically it. So it covers all the major topics for multivariate analysis, which would nowadays be known in machine learning. The book is kind of rigorous, not too much, but it's the main ideas are there, and the main ideas are presented mathematically with matrices and with mathematical notation. The proofs are kind of there. The most important things are not proven because they're too difficult. But yes, I really do like this book, and I think I would recommend it as a book I would like for multivariate statistics. Then we come to Gelman and Hill's Data Analysis Using Regression and Multi-Level Hierarchical Models, which is basically the book I would recommend for multi-level analysis, for longitudinal analysis. So part 1A is about single level regression, which is the usual regression in one variable that you know, like it even covers logistic and generalized linear models. Then we have inferences. Then we have multi-level regression, multi-level structures, multi-level linear models, logistic regression multi-level, generalized linear models, fitting multi-level models, and then from data collection to model understanding to model checking. So yeah, it's really nice. I think this would be my favorite book on multi-level analysis. Of course, it's by Gelman. He's a really good writer, and he's really careful in applying the statistics, and is very known for doing this. So definitely a book I would suggest for that. Here we have a book on genetic algorithms plus data structures evolution programs by Machalevich, which is basically a book on genetic algorithms, which are algorithms which evolve over time. Just like evolution, biological evolution. We want programs to evolve over time and to basically improve themselves, and we choose the most successful programs every single time. So we have a part on genetic algorithms, we have a part on numerical optimization and how to do fine-tuning and handling constraints. Then we have evolution programs with transportation program, the traveling salesman program, machine learning. So yes, I never quite got into reading this book. I really am very interested in it though. It seems like a very interesting approach to doing things, especially since the link to biology interests me a lot. But yes, it's pretty cool. It's pretty cool that this even works and this is even a thing. So yes, yeah, I think I do kind of like this book. Next we have Using R with multivariate statistics by Randall Schumacher. Basically is an how-to book with R, and it covers the usual topics for multivariate analysis. Multivariate analysis of variance, covariance, repeated measure, discriminant analysis, canonical correlation, factor analysis, principal component analysis, multidimensional scaling, and structural equation modeling. And the book is basically just how to do it in R and how to interpret your outcomes. There isn't much theory in this book at all. It's basically a how-to book. I'm not sure I would recommend this book really. Unless you really want to do it in R and you already know the theory, I guess. Here we have data analysis and graphics using R by Main Donald and Brown, which is again an how-to book in R, but this time for more to the graphics side, to the data analysis side. So we have an introduction to R. We have styles of data analysis, statistical models, a review of inference concepts, regression and single predictor, multiple linear regression, exploiting the linear model framework. We go on to generalized linear models and survival analysis, time series models, multi-level models and repeated measures, tree-based classification and regression, multivariate data exploration discrimination, regression on principal component and discriminant scores, the R system, and yeah, that's it. Graphics in R, graphs in R. So yes, it's again a how-to book of how to implement things in R. Don't expect too much beautiful statistical theory and derivations in this. It's basically how to do things in R most efficiently. So yes. Here, the next book, we have Handbook of Missing Data Methodology by Molenberg, Fitzmaurice, Kenworth, Tsiatis, and Verbeke, two of my professors at university. And it is all about missing data and how to handle missing data, a subject I am particularly interested in because it's very cool and it actually relates to a subject I'm interested in, namely information theory. So yes, it is written by experts in the fields, but yeah, it's a kind of overviews. It's kind of not rigorous derivation, but overviews in what to do and when to do them, and yeah, like a typical statistics book, I guess. Nothing too mathematically rigorous. Here we have a book by Heath on Greek astronomy. Heath is, of course, the writer who wrote a lot of books on astronomy, on Greek mathematics rather, and this one is on astronomy. astronomy as done by Thales, Anaximander, and so on, the Pre-Socratics, Plato. It goes on to deal with Aristotle, Euclid, Aristarchus of Samos, Eratosthenes, Aratus, all the way to Ptolemy, of course. So it deals with what the Greeks thought of astronomy, and of course this is very essential what he thought of astronomy, because this is essentially what led Newton to making the discoveries he made, because Newton was response on Copernicus, and Copernicus was response on Ptolemy and the models of Ptolemy. So if you want to understand where Newton came from, you first have to understand the framework of the Greeks. And this book does it excellently, of course. It's a Heath book, so it's Heath is very careful, maybe a bit too careful if you don't want all the details done, but yeah, this is a pretty neat book. Next we have here Multi-Paradigm Programming Using C++ by Vermeer, who was one of my teachers who taught me C++, and I absolutely hated that course, and I think the book is not good at all. I didn't really like the book at all, and maybe I didn't appreciate the book at first. Maybe I'd appreciate it better now. But yeah, I think the book was not quite mathematical enough. How should a programming book be mathematical, you ask? Well, maybe mathematical examples, or like SICP from Abelson and Sussman is a book that's mathematical, that I really like. Of course, the class was meant for computer science majors, so I mean, they're not gonna make it mathematical just for me. I get that, but yeah, I mean, hence why I didn't really like the book that much, and the class as a whole. I guess they kind of lured me into computer science from the very first course, which was programming and use structures and which use SICP. And then I was sold and I was going to do this, and then basically it kind of got a lot worse after that. Here we have a very good book, The Geometry of Multivariate Statistics by Wickens. Deals with multivariate statistics and how to interpret it geometrically. And with geometrically, they mean linear algebraically. So they have vector geometry, where they introduce vector spaces, bivariate regression, multivariate regression, regression vectors, statistical tests. They have conditional relationships, the analysis of variance, principal component analysis, and canonical correlation. It's all about the geometry of statistics and how to interpret geometry statistically. So I really think this is a very good book that you should read in order to understand these things geometrically. If the book doesn't tell you, this is very worthwhile in doing things. It really gives you a very new understanding, a very beautiful understanding that maybe would be very useful for you later on. Then we have here Time Series Analysis and Applications by Shumway and Stover, which just deals with time series, and it has all the usual suspects on time series. It has ARIMA models, it has spectral analysis and filtering, it has state space models, and it has statistical methods in the frequency domain. So yeah, it's all about time series and how to deal with basically things depending on time and how we should analyze it and what possible methods we should use. Time series is extremely interesting and really relates to a lot of deep math like Fourier analysis. So yes. Very interesting, and this is basically a book with R. So it is there is an entire Springer subsets that deals with R, and those are not the most theoretical books, but basically all tell you how to do it in R. So if you're interested in doing things in R, then this would be a good book for you.